Hello, in this video we're going to define the trigonometric functions. That is, we're going to define sine of x, cosine of x, and tangent of x. So, we start out with a right angle triangle like this one. And the right angle triangle has angle x, which means this angle up here must be 90 minus x, but we're not going to get into that one. So our right angle triangle has angle x, and we know already that the length of the longest side of a right angle triangle, the one that's opposite the 90-degree angle, the length of the longest side of a right angle triangle is called the hypotenuse. The hypotenuse. And we're going to suppose that the hypotenuse side has length h. Hypotenuse side has length h. My pen's playing up. Hypotenuse side has length h. There we go. Okay, and now, when we're paying attention to this angle right here, the one in yellow, we say that the opposite side is the one that's not connected to it. In other words, the opposite side is the one that's opposite to the angle. And so our opposite side, we're going to suppose it has length OP. Now, the reason I'm calling the length OP is because if I just call it O, it looks like a 0, and then all of our calculations are going to get confusing later on. So the opposite side has length OP. And finally, the other side is the adjacent side. So it's the side that's connected to the angle, but not the hypotenuse. So, and the adjacent side is going to have length A. All right, and of course, we can see just from the picture that I've drawn by the definition of triangles that it must be the case that 0 is less than x, which is less than 90 degrees. Okay, so we can define our trigonometric functions now for 0 less than x less than 90 degrees. Okay, and our trigonometric functions are going to be defined as follows. Sine of x, so for 0 less than x less than 90 degrees, and a right angle triangle that looks like this with angle x, we have that sine of x is equal to the length of the opposite side divided by the length of the hypotenuse. So that's OP divided by h. And we're going to see that also we're going to define cosine of x is equal to the length of the adjacent side divided by the length of the hypotenuse. So A divided by h. And finally, tangent, which is just written as tan of x, is going to be equal to the length of the opposite side divided by the length of the adjacent side. So OP divided by A. Now, if you watched the video about similar triangles, you would realize that actually for any triangle that has the same three angles, these ratios don't change. So if I drew another triangle that's a right angle triangle and it has angle x, and I call these lengths A, B, and C, then actually OP divided by h is going to be equal to the length of the opposite side on this one divided by the length of the hypotenuse. So OP divided by h would be equal to B divided by A. So in fact, these three functions can be defined for any right angle triangle you choose as long as it has angle x. So sine of x can be defined for any right angle triangle you choose that has angle x, because we showed in the previous video that those ratios don't change for similar triangles. Okay. Well, that's all well and good, but unfortunately our definition so far only works for x between 0 and 90 degrees. So what we're going to do now is we're going to extend this definition. So let's go to another board. So how are we going to extend this definition? Well, we're going to go ahead and keep drawing triangles, but we're going to draw it on a graph. So here's our x and y axes. So this time our triangle is going to go over here. So it still has a hypotenuse of length H still has an opposite side of length OP, and it's still, but the problem is, well, for our old triangle, which was facing in this direction, because that's purely just the way I decided to draw it, but it works well with this graph. For our old triangle, we had a length of A for our adjacent side. So this length here was the length A. Well, now we are reflecting our triangle about the y-axis. We're reflecting our triangle about the y-axis. So the value over here is actually going to be negative A. So the length of our reflected triangle, I know it sounds a bit silly, length is actually therefore the wrong word. The coordinates of this point on our reflected triangle is going to be negative A. And so that's how we're going to extend our definition to angles of x that are further than 90 degrees. We're going to call this point negative A. Notice that this, I'm not going to say length anymore, notice that this point up here still has a height of OP, whatever OP was, because this triangle has just been reflected. The height hasn't changed. The height is still the same. However, the base, the distance across, since we're reflecting the triangle in the y-axis, it makes sense to give it a negative value. And now we're ready to extend our definition, because if I draw an angle x that's now between 90 and 180, for example, this one right here, I still have a perfectly good set of values to plug into my functions. So for x between 90 less than x less than 180, we can now clearly see that a sensible definition, if we're going to define it by reflecting triangles, we can see that sine of x is now equal to OP, still equal to OP divided by h, and cosine of x this time is equal to negative A divided by h. Now remember, A itself is this length here, so length is always positive, remember. A is that length, but because we're now graphing the triangle, it's negative. So cosine of x for x between 90 and 180 is equal to negative A divided by h, where this can be any triangle, although the angle of our triangle in question now must be 180 degrees minus x, because x plus 180 minus x better equal 180, because this is a straight line, and angles in a straight line add to 180 degrees. Okay, finally, tangent of x is still equal to, well, the opposite side divided by the plotted point of the adjacent side. So in this case, it's OP divided by negative A. Okay, we can keep doing this. We can keep going around. So let's do one more so that you get the idea. Let's now we're going to not only reflect it about the y-axis, reflect our triangle about the y-axis, we're also going to reflect it in the x-axis. So this is now our triangle. So we started out by reflecting it about the y-axis to get to here. Now we've reflected it about the x-axis to flip it upside down. And that's the triangle we're left with. This angle here, well, since this angle is 180 degrees, and the whole angle right around to this line is now x, the angle of our triangle must be x minus 180, x minus 180 degrees. See if I can write that better. X minus 180. Okay, well, that's an 8 in the middle if you get confused. Should have drawn this triangle a bit bigger, shouldn't I? Okay, so now let's take a look at the plotted values Well, the h still stays the same because h is the length of this line, and we can't really plot h as a point. It's kind of hard. However, we can plot this corner as a point, and we can plot this corner as a point. So now the height of our triangle is actually going to be, well, not the height of our triangle, the plotted point of our corner is going to be negative OP. It's going to have a y value of negative OP because we're going OP downwards, where OP is the height of the triangle. The base is still A, still has a length of A, so the plotted point at the back there is going to be, oops, that looks like a 9, negative A. And hence we can get the rest of we can get our cosine values now for 180 less than x less than 270. 180 less than x less than 270, we can see that in fact sine of x is equal to negative OP divided by negative A. Wait, that's not right. Negative OP divided by h. Sine is always equal to opposite divided by hypotenuse. Cosine of x is equal to negative A divided by h, and tangent of x is equal to negative OP divided by negative A. Tangent is always equal to opposite divided by adjacent. So negative OP divided by negative A. Well, in this case, the negatives cancel. So tangent of x is equal to opposite divided by adjacent again. All right, and our triangle, of course, has to have angle x minus 180 degrees. X minus 180 degrees, where 180 is less than or equal to x, less than or equal to 270. So, of course, this angle here will be between 0 and 90 degrees, in case we couldn't tell just by looking at it, which we could. Okay, so yeah, we can do, you can do a fourth one. I'll leave that one as an exercise, or you can read the notes. I did it in the book, and that will give you angles of x between 270 and 360. Okay, so that finishes that off. And finally, you can go backwards as well. Let's just do one going backwards to define negative values of x. Draw this line higher. So here's x, here's y. Wow, I just realized it may be a little confusing if I'm calling the angle x and also the variable along here, x. Those are two different things. I apologize if that caused any confusion. One of the x's is an angle, the other one is the x-axis. So yeah, please don't get tripped up by that. If you do, it's my fault. I take full responsibility. Okay, so now we're going to define cosine, sine, and tangent of negative angles. We're going to flip our right angle triangle up exactly like this, except we're going this way now. So if this right angle triangle has angle x, then by going in the clockwise direction, we've actually traversed negative x, because clockwise angles are always negative and anti-clockwise angles are always positive. The reason why is just because it makes all our calculations in physics and everything much easier if we give one of them a positive direction and one of them a negative direction. So this is the negative direction. It has the triangle itself will have angle positive x if you just think of it as a triangle, but when it's plotted on this graph, it has angle negative x because we're including the direction of the angle. Okay, so that's negative x. Well, this triangle, again, the triangle itself will have height OP, but when we've plotted it on our graph, it's actually going to be negative OP. And similarly, well, it's going to have the length of the adjacent side A, and when we plot it, that actually doesn't change this time. And of course, the hypotenuse side is always going to have length h, because that always stays as a length. We can't really plot that. Alrighty then, so now cosine of negative x, I'll write it down here, cosine of negative x is actually equal to a divided by h. a divided by h. Well, that's the same as cosine of regular x. If you go back to the first one, cosine of regular x was always going to be a divided by h. It's always whatever the adjacent plot is divided by whatever the length of the hypotenuse is. And so if 0 is less than x less than 90, and we take cosine of negative x, it's actually the same as cosine of positive x. So that's pretty good, isn't it? Okay, and also we have sine of negative x is actually equal to negative OP divided by h. And if you think back to the start, that's equal to negative sine of x, because sine of x was equal to OP divided by h, so this time it's equal to negative sine of x. And finally, tangent is equal to negative OP divided by a. So that's tangent of negative x. Tangent of negative x. Hopefully you can see that negative sign. Maybe I should start that one again. Tangent of negative x is equal to negative OP divided by a, which is equal to negative tangent of positive x for x between 0 and 90 degrees. Okay, so that should give you some insight onto how we're defining these functions. I think I go into a bit more detail in the notes, so make sure you check those out, and also make sure you attempt the exercises at the end. Thanks very much for watching, and see you guys next time. Take care. Bye.